Hi everyone, welcome back to the channel, and today we're going to solve Leetcode daily challenge problem number 19. Remove nth node from end of a list. So it is tagged as a medium problem, and it is a easy problem to solve if you know the concept, a few concepts. So we'll first check out the problem statement, then we'll look into the approach which you're going to use, and towards the end we'll see the code as well. So starting with the problem statement, it is given that we'll get a head of a linked list, and we have to remove the nth node from the end of the list and return its head. Okay, so now for example, um, this is an example, okay, in which the linked list has 1 2 3 4 and 5 as their nodes, and the n given is 2. So 2 from the end will be what, 4, right? So you will basically just update the pointer of the previous element, which is 3, from pointing to 4 to 5. Okay, so essentially this is what we have to do, but the interesting thing is, like, how will you figure out this one? Because in linked list you just cannot use indexes, or you cannot traverse it in the other way, until unless you just update the whole linked list and do that. So um, we'll be using a approach, that will have two pointers, and we call it fast and slow pointer approach, in which what I will be doing. So by the way, this is the exact same example, and in this approach I'll be using two pointers. First one will be a slow pointer, okay, another one will be a fast pointer. So I have kept these names because I just wanted to reflect that fast pointer will reach in a little quicker, okay, and slow obviously, like, will follow fast. So how I'm gonna do this? So as you can see, the we have you know we have the difference from the last element, right, which is 2. Now what if I initially, when I'm defining these two pointers, what if I introduce a difference between these two pointers? For example, if slow is pointing at 0 and fast will point at 2. I'm talking about, okay, let's change it. Let's keep the elements on. For example, slow is pointing at 1 and fast is pointing at 3. Okay, so this is our slow pointer, and 0 1 2 will be what, yeah, this one. Okay, fast is this. Now if I keep this difference constant and move the pointers, you will see that we will reach this kind of a setting where my fast pointer will be at this one and the slow pointer will be here. Okay, and if you see, this is the element which we want to remove, right? So basically we were able to figure out the element which we wanted to remove. Okay, but there is a catch. If you do this way only, you ended up on the element which you want to remove, right? You should have been on the previous pointer, and that would have made all the operations a little simple. So to solve this, what I'm going to do, I'm going to use a hack, and I'll use the exact same approach, but what I'll do, I'll add a additional node in front of the given linked list. Okay, and I'll start my operations from here. Okay, so now if when you reach to the end, basically your slow pointer will be pointing to the previous element of the node which you want to remove. Okay, so this will be the approach which we'll be using. Let's check out the code. It will be a very simple one. Okay, so first we started with the creating a new node, and we initialize the value with 0. It doesn't even matter, like, what the value over here is, and it is pointing to the actual head node. Okay, now initially our fast and slow pointer is pointing to the new node only, but remember the part where we discussed that we initially will introduce the difference between the two pointers. So this is the part where we are introducing the difference. So what we are doing, we are uh, moving the fast pointers n nodes further than the slow pointer. Okay, so they both started at new node, but we have made the fast pointer go ahead of the slow one. Okay, Now it's a simple loop, like how you traverse your linked list, and the check will be on the fast pointer. As soon as the fast pointer reaches to the last node, this loop will be over. Okay. And as we saw in the explanation that the slow pointer will be pointing to the node previous to the element which we want to remove, or node previous to the node which we want to remove, then what we will do, we will update the pointer which is slow.next to slow.next.net. For next, for example, slow was pointing to 3, so so now the next element to 3 will be, so this next will represent basically 4 and this will be 5. So you have basically removed the fourth node, okay, from the example which we just saw. And at the end you are returning the original head using our new node, and we are doing that by using the next attribute. Let's check out the test cases. And as you can see, the test cases got accepted. Let's submit it for further evaluation now. And by the way, like you can use other approaches. For example, you can create your own like you can update the whole what do you say, linked list and reverse it. So as you can see, the test the solution got accepted and we have performed fairly well. So yeah, this was the solution, guys. Thanks a ton for watching out the video. Stay tuned to the upcoming ones. Don't forget to like the video and subscribe to the channel. Thank you.